Hey guys, welcome to my second YouTube video. Thank you for joining me. We're here today to take a look at the single responsibility principle, the first in the solid principles. First of all, if you're watching this, I recommend, if you haven't already, check out the solid overview that I did about a week ago. A link to that video can be found in the description. And if you're up for coding along with this, there's also a link in the description to a GitHub repo that contains the sort of starting code, essentially, of where we're going to begin today. Feel free to code along, and then you can use that code to sort of carry on coding after the video is done, and you want to carry on making some further changes yourselves. So, single responsibility then. So we covered this in the overview very briefly, as classes should have one and only one reason to change. And the idea behind this is that classes become sort of narrowly defined as carrying out a particular function. And the idea is that class responsibility doesn't overlap with other classes, and the functions and the services contained within them are all sort of narrowly defined as well, so there shouldn't be any sort of scope overlap with other areas. And the idea behind this is to obviously make sure that when you come to make changes to classes and stuff like that, that you're only changing one area of the functionality, not several. And you know, in turn, that makes code then a lot more maintainable because things are in their own different pockets of maintainability. It becomes much more supportable, and ultimately a lot more flexible as well, because you've got a lot more scope. You can see what kind of stuff you're doing, and you know, you can edit away as free. So I've come up with my own version of the SRP, my own example of SRP. I've reviewed a number of different examples online over the last few days, and there's a lot out there that can be quite complicated, I think, and unnecessarily complicated. You know, I will say in advance that the code that I've got today is very, very simplistic. You know, we're not sort of looking at classes that have hundreds of lines of code or anything like that. But one of the things that I want to make clear is, you know, this is just to give an understanding of what SRP is designed to achieve, not to show you a sort of real world example of where we can implement things. By all means, if people want real world examples, you know, please leave a comment, let me know. I can always create some additional coding examples and upload those to GitHub repos, should people want them. So, you know, feel free to chime in. So the example that I've got today should hopefully be familiar to an awful lot of software developers out there, and it is a bug lifecycle. So what I've done is looked at the areas of responsibility within, you know, a bug and its development lifecycle. I suppose, you know, sort of roughly the software development lifecycle in general. And I've tried to create sets of code that sort of display what happens during that process and how there's different roles and they shouldn't all be in the same place. Alongside that, I've got some tests that we'll go over as well, because I thought it would be really beneficial to show how refactoring for SRP can make tests a lot more manageable for different areas, and you know, help you write cleaner, clearer tests essentially for development. So without further ado, let's get cracking. So we've got this class of a bug lifecycle, and in here we've got this bug that's visible to us, and essentially this bug is just a basic sort of model class with a few properties in there of strings, ints, bools, just to sort of say, you know, how many development hours, test hours, is it developed, is it tested, that sort of thing. And we've got a few different steps in here. So the first step that we've got is that a customer reports the bug. So they create the bug, give it a name. We then have a step that product plans the work. So product comes together with the testers, the developers. You know, they make sure that the bug, first of all, exists, that it's got a name, it's been raised properly. And then they put some hours against it, mark it as planned. We've then got a little method that the developer does does the work, fixes the bug, or in this case, it's the console write line doing some coding. And then the tester does the testing, and obviously is tested is true, is developed is true. So very, very straightforward example, but obviously we can see straight away that the bug lifecycle shouldn't be responsible for, reporting the bug, planning the work, doing the fixes, and doing the testing. And the idea here is that all of these things are in this same class, and that breaks SRP, because we know that, for example, the customer generally is on the outside of the development teams, outside of engineering. Sometimes it happens within that kind of area, but very rarely. So they need to be scoped out completely. Product as well, not really the same responsibility, planning the work as well as raising the bug, as well as doing the development, doing the testing, and again, development and test. So what we're going to do is we're going to very simply start splitting out the responsibilities here. And we're going to start with this customer reports the bug. So ideally what we need here is a customer class. So normally what I would do is I would refactor away with resharper and shortcut keys. But I'm very conscious if people want to sort of code along, I'm going to do this the long way. Probably make a few mistakes along the way, but I'm only human. So we'll create a new public class called customer. What we'll do is we'll give that a constructor, and in that constructor we'll take a bug lifecycle, because we're going to need all of these classes to be aware of the same bug lifecycle. Now, the way that I'm doing this isn't necessarily the cleanest way. Further down the line, when we cover other responsibilities like dependency inversion and stuff like that, we'll look at better ways of doing this, but with other examples. So for now, if you're a seasoned veteran, just turn a slight blind eye to some of the horrible things I'm going to do here. So we'll call this bug lifecycle. No, we won't, because I can't type with a massive microphone in my face. And we'll create a read-only field of bug lifecycle, but I'm going to get rid of the read-only for the time being, because we are going to need to edit stuff on the fly. And then essentially what we can do, this method here for customer reports the bug, we can take this out, essentially, and we can put that in here. And then this simply becomes the bug lifecycle .bug. Now, obviously at the moment, the first problem that we get is that the context, the set, is exclusive to the bug lifecycle class. So we can fix that quite easily. Get rid of that private set. So obviously at the moment we have a customer, but we've not newed it up anywhere or anything like that. So what we're going to do is we're going to make the bug lifecycle responsible for basically collating everything. So whilst we're shipping the code out, the code's going into the customer class, there still needs to be somewhere for us to collate it all, and that's what the bug lifecycle is there for. It's there for collating everything rather than doing everything. So we'll have a public customer. We'll give that get setter, and then we'll take a constructor in here, and we'll just say that customer equals new customer. Again, shortcut keys really aren't my friend today at all. I'm doing incredibly well. And that, of course, the customer wants an example of the bug lifecycle, so we're just going to pass itself in. So there we go. We've got the, in fact, we can get rid of the set from there. So we've got a customer now. We've got the code shipped out, and we will eventually have things that call that. And we'll come to the tests in a minute. You can probably see up the top, the tests have got a nice red line under them, and we'll come to those later. So that's the customer sort of separated out. So we've now got this customer class here. We can move that out into its own file, which gives us all of that. And essentially now the bug lifecycle is one stage less. So let's do the same with the product. So we'll have a public class. We'll call this one the product owner, because that's generally what they're called. And this too will have a constructor that takes a bug lifecycle called bug lifecycle. Shortcut keys this time working beautifully. Remove the read-only field, and again we'll take this code here, snap it up here. And again, we can just go through and change a lot of these properties now to reference the bug lifecycle directly. Copy and paste is your friend, unless, like me in the past, copy and paste hasn't been your friend. Always be careful with copy and paste. Can very often lead you wrong. And again, here we need a public product owner. And again, we'll instantiate this within the constructors. So product owner equals new product owner, passing in this. Job done. Okay. So product owner done. Really, really simple, refactoring stuff out. But are we starting to see that it sort of makes sense? The bug lifecycle isn't responsible for doing this work. It's responsible for collating all of the things that have been done because that's part of the lifecycle, but it's not responsible for doing. Now, we'll come back to the product owner class in a minute because you probably spotted, or maybe you haven't, that there is some cross responsibility in here. We'll go through and we'll refactor out the development and the test classes first, and then we'll come back to the product owner class and sort that out in its own time. So let's do the same for a developer. So public class developer. Same again, constructor that takes a bug lifecycle. Remove the read only. And then again, we'll nick this code from down here. Stick it in there. And again, copy and paste is your friend. And then again, we can put in a property here. So public developer. No, shortcut keys failing me again, honestly. And to think I recommend Rider. Note to self, I might need to have a look at my shortcut keys at some point and just make sure everything's in the right place. So again, we'll instantiate this from here. So new developer, passing in this bug lifecycle. Beautiful. And finally, the tester. So what we'll do now is we'll refactor this. So we'll extract a class. We're going to call this not developer because that's the one we've just done. We're going to call this tester. There we go. So you'll notice we've stripped out the tester class as well. So let's move both the developer and the tester to their own classes. And again, you can see here now we've got this, but I don't want to go ahead. Use this method, this way of doing properties. So we're going to do that. We'll get rid of that, and we'll just do tester equals new tester with this. Beautiful. So there we go. So straight away we can see the bug lifecycle now has absolutely no code in it. Yeah, we've got the constructor, which is responsible for, in our cases, creating the customer, the product owner, the developer, the tester. Not necessarily the best way to do this, but for the purpose of this example, it's fairly straightforward and relatively simple enough. And then alongside that, we have obviously the public properties, which we're going to make use of shortly within the tests. And all of that code is now removed out. So the beauty of it is, let's say, for example, if we wanted to change some of the work the tester did, for example, down here, all we would need to change is the tester class. And the benefit now is that if we change the tester class, we don't need to change the bug lifecycle class, which meant we'd need to change a whole host of different things or areas of code that weren't necessarily applicable to the tester. And the same applies for the others. So the same with the development class, product owner class, customer class, etc., etc. It just makes everything a lot more clean, a lot more understandable, and obviously a lot more flexible, which is what Solid is designed to do. Okay, so before we approach the tests then, you may remember a few minutes ago I mentioned that we were going to have a look at the product owner class a little bit closer. So what we've got here is test hours and development hours. Now, you remember I said at the start, the idea around SRP is that the functions and the methods don't overlap. So the product owner, it's not the product owner's responsibility to provide test hours or provide development hours. Those should be the responsibility of the tester and of the developer. Okay, so what we're going to do is at this point here, we're going to go to the bug lifecycle and go to the tester, and we're going to create a method called get test hours, like so. Now this method doesn't exist at the minute, but what we can do is we can create a method using the refactoring, and we'll just get this to return 4 as it was before, so that's fine. I'm being very, very simple there. Completely forgot to put the return on. Glad to see my brain is working as expected. And we'll do the same with the developer hours here. So can't type again with a massive microphone in my face. So developer.get developer hours. And again, we'll create the method. We'll zoom in a bit there and return 6 in this case. So straight away there, what we've done is refactor out even more code. So now, again, you know, the product owner is not responsible for providing the test hours or the development hours, because if we needed to change either of those or how they were calculated, perhaps, maybe there's a more complicated method of calculating the hours, we would have to come in the product owner class and change it. And that's not the responsibility of the product owner class. What we've got now is separate methods within the developer and the tester classes, and we can change the logic here to our heart's content. And ultimately, what comes out at the product owner side of things doesn't really matter, because it's reliant on the developer and tester classes as per SRP. Okay, so I've waffled on quite a lot there. Hopefully everybody's managed to keep up. What we'll do now is we'll have a look at the bug lifecycle test themselves. And one of the first things that I want to point out is that straight away you can see that the tests within this class, there's quite a lot of them, and there doesn't need to be. And one of the things that SRP gives us, as well as the maintainability and the flexibility, is to have crystal clear tests, right? So we've got tests in here that are for the customer, for example, so that when the customer reports the bug, we expect that the bug name is the same as what's actually been reported. And they're not the responsibility of the bug lifecycle test. They're the responsibility of is actually the customer. So now what we can do is we can refactor the tests out into individual test classes. So we'll do one example. I'm not going to do loads, because one of the things that I would encourage you to do after this video is perhaps go in using the demo code that's on the GitHub repo and refactor some stuff yourself, just to see how you can, so that you can see how things pin together essentially. So we'll go ahead and we'll do one. So we'll do public class customer. I did spell that right. I didn't think I did. Okay, and we'll create this as a test fixture, and we'll extract this to its own file straight away. And what I'll do, because we'll be using the same sort of setup and the same system under test and stuff like that, I will simply copy these things over and we'll import the missing references. We won't need that, so we can get rid of that. And essentially the first test that we've got is this. So we can nab that test straight out of that class and put it straight into here. And this wants to become the customer, like so. And in theory, what we'll have to do is we'll have to comment out all of those, because otherwise the build will fail. If we run this, God willing, the test will pass and I will look incredibly clever, which is remarkable. So there we go. You can see that what we've done is we've refactored out the test into its own class. So anytime we write additional functionality for the customer, we can come in here and we can write additional tests. And that doesn't clutter up the tests within here, which for all intents and purposes we could get running quite easily. So we could just do this one here, for example, and take that to the product owner level. We could take this one to the customer level, and then this one here to the product owner level, and these two tests would run, right? So if we just come down here, comment out that, we'll have to comment out this as well. Yeah, we could run the tests in this class now, and in theory, these should run as well. So the bug lifecycle tests, they run absolutely fine. But the point is, the tests for the planning, the tests for the fact that product cannot plan unless a bug is reported properly. So in our case, you know, it's got a name or it's not null. These shouldn't be the responsibility of the bug lifecycle. So again, you can refactor these out into a product owner tests and have those completely separately. So there we go. Relatively short, snappy overview of SRP and how to implement it, given a very, what I hope is straightforward example. If you've enjoyed the video, please hit the like, subscribe, and ring the bell for notifications. As I say, there are more videos up and coming. Next one is Open Close Principle, and I'd love it if you guys can come along for that and leave some more comments. So thank you very much for watching. Hope you've enjoyed it. I'll see you next time. Bye-bye.